New Google Gemini update is insane. Google just changed everything. Most people are using AI wrong. They're getting surface level answers when they need deep thinking, and they're missing the biggest update in AI reasoning this year. Google just dropped a major upgrade to Gemini 3 Deepthink. This isn't your typical AI update, this is different. And if you're working on anything that requires actual thinking, real problem solving, or complex reasoning, you need to know about this. Most AI tools work like this. You ask a question, they give you an answer instantly, fast, but often shallow. They're pattern matching, taking what they have seen before and piecing it together quickly. Deepthink works completely different. It thinks like a scientist. It explores multiple solutions at the same time. It tests different approaches. It verifies its own work, and it takes time to get it right. The results: gold medal performance on the International Math Olympiad, gold medal on the International Physics Olympiad, gold medal on the Chemistry Olympiad. These aren't just benchmarks. These are the hardest problems students face worldwide. But here's what makes this update different from everything else. They didn't just make it better at tests. They made it practical. They made it useful for real work. One of the biggest features is Sketch to 3D printing. You can literally draw something on paper, upload it, and Deepthink analyzes your sketch, models the geometry, checks the physics, and generates a 3D printable file ready to go. Before this, you needed to know CAD software. You needed expensive tools. You needed technical knowledge. The whole process took hours or days. Now, you sketch it, upload it, and you're printing. Engineers are using this for rapid prototyping. Designers are testing ideas the same day they think of them. Students are turning homework concepts into physical objects. The real power is in how it thinks. Deepthink scored 84.6% on something called ARC-AGI2. This is a benchmark specifically designed to test if AI can solve problems it's never seen before, not memorization, not pattern matching. Actual reasoning is scored 48.4% on humanity's last exam. This is a test designed to push the absolute limits of AI models, and it's doing better than any other system out there. On Codeforces, which is competitive programming, has an ELO rating of 3455. That puts it at the level of top competitive programmers worldwide. Let me show you how people are actually using this. Lisa Carbone is a mathematician at Rutgers University. She works on bridging Einstein's theory of gravity with quantum mechanics. She used Deepthink to review a technical mathematics paper. It found a subtle logical flaw that human peer reviewers missed. Think about that. A paper that went through expert review. Multiple people checked it, and Deepthink caught something they didn't. At Duke University, the Wang Lab used Deepthink to optimize crystal growth methods for semiconductor materials. This is cutting-edge research, and Deepthink helped them move faster. So how does Deepthink actually work differently? Most AI models give you one answer, fast. Deepthink explores multiple paths at the same time. It's called parallel reasoning. Imagine you're solving a complex problem. Instead of going down one path and hoping it works, Deepthink tests 5 different approaches simultaneously, compares them, finds which one is strongest, then gives you that solution. This takes longer. Instead of instant answers, you might wait a few minutes, but the quality is completely different. Deepthink excels at interpreting messy data, real-world data, the kind where there isn't a clear answer, where multiple factors are at play, where you need to think through different possibilities. It's built for problems without guardrails, where you don't have a single correct solution, where the data is incomplete, where you need to make decisions with uncertainty. This is how most real work actually happens. You're dealing with incomplete information, competing priorities, multiple stakeholders, uncertain outcomes. For anyone doing research, engineering, or technical work, this changes your workflow. You can model physical systems through code. Deepthink understands the physics. It can simulate how things will behave. It can tell you if something will work before you build it. You can analyze complex data sets, find patterns, identify correlations, get insights that would take days of manual work. You can solve optimization problems, whether it's logistics, resource allocation, or process improvement. Deepthink can explore the solution space and find better approaches. And the Sketch to 3D feature isn't just about printing random objects. It's about iteration speed. You have an idea, you sketch it, Deepthink models it, you see if it works, you modify it, you test again, all in the same day. This kind of rapid iteration is how breakthroughs happen. Now, let me be clear about something. Deepthink isn't replacing human expertise, it's amplifying it. Lisa Carbone didn't stop being a mathematician. The Wang Lab didn't stop doing research. They used Deepthink to accelerate their work and catch things they might have missed. Let me show you the benchmarks that matter for real work. On theoretical physics problems, Deepthink scored 50.5% on CMT benchmark. This tests advanced physics understanding, the kind used in cutting edge research. On engineering tasks, it can generate code that models complex systems, simulate fluid dynamics, calculate stress points, optimize designs. On data analysis, it can handle large data sets with missing information, find meaningful patterns, test multiple hypotheses, give you actionable insights, and all of this is available now. If you're a Google AI Ultra subscriber, you can access Deepthink today in the Gemini app. Just select Deepthink in the prompt bar. And for the first time, they're opening it up through the Gemini API. Researchers, engineers, and enterprises can apply for early access. This means you can integrate Deepthink into your own workflows, build custom tools, automate complex reasoning tasks. You could build a system that reviews technical documents and catches logical flaws. You could create a tool that analyzes experimental data and suggests next steps. You could develop a workflow that turns design concepts into testable prototypes. Now, I want to talk about what this means for the bigger picture. We're moving beyond basic AI chat, beyond simple question and answer, beyond surface level pattern matching. We're entering a phase where AI can actually reason through complex problems, where it can handle ambiguity, where it can work with incomplete information. For students, this means you can learn difficult concepts with an AI that actually explains the reasoning, not just the answer, the steps, the logic, the thinking process. For professionals, this means you can tackle harder problems, test more ideas, move faster on complex projects. For researchers, this means you have a tool that can help verify your work, explore alternative approaches, catch mistakes before they become bigger issues, and we're still early. This is the first wave of really strong reasoning models. The quality will keep improving, the speed will get faster, the applications will expand. If you're not paying attention to these tools, you're going to fall behind. The sketch to 3D feature is working, the reasoning improvements are real, the benchmark results are verified. This isn't hype, this isn't marketing, this is a legitimate step forward in AI reasoning capability. And if you're working on anything complex, anything technical, anything that requires deep thinking, you should be testing this immediately. The people who figure out how to use these tools effectively will have a massive advantage, not just in getting work done faster, but in solving problems other people can't solve. That's where the real value is. Not in replacing human thinking, but in augmenting it, in pushing what's possible, in exploring solution spaces that were too big to explore manually. Google built this by working directly with scientists and researchers. They focused on real problems, messy data, incomplete information, the kind of challenges people actually face, and that shows in the results. This isn't a toy, this isn't a gimmick, this is a serious reasoning tool for serious work. The question isn't whether these tools will change how work gets done, they already are. The question is whether you'll be part of that change or left behind by it. Test Deepthink, learn how it works, find where it fits in your workflow, and start using it before everyone else figures it out. Because once everyone knows how to use these tools effectively, the advantage disappears. Right now, there's still time to get ahead, don't waste it.